Welcome. Today we're going to continue talking about roots, both square roots and cube roots, but we'll be estimating them. But by now we should know that, let's say, the square root of 4 is really 2 squared, and we take one of those away in it with the answer 2. And to try another one, let's say the square root of 25 is really 5 squared, and we take one of those away, we end up with the answer of 5. So these are the perfect squares up to the number 25. But what about the square roots of the numbers between 1 and 4, and 4 and 9, and 9 and 16, and 16 and 25? These numbers between the perfect squares also have square roots. It's just that they don't come out to an even number. When square rooting these numbers in between the perfect squares, we get what is called an irrational number, which is a number that is never ending and keeps on going in decimal fashion. It can never be made into a fraction or a rational number. So let's begin with estimating some of the square roots that are in between the perfect squares, such as 15. The idea is to find the two perfect squares closest to 15. So I just begin counting. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. And we see that the numbers 9 and 16 are very close to 15. In fact, 15 rides right between them. So if we take the square roots of all of these numbers, we find the square root of 9 is 3, and the square root of 16 is 4. So the square root of 15 is somewhere between 3 and 4. We now need to determine which one is closer to 15. The square root of 9 equals 3. The square root of 16 equals 4. And you can see by the number line that 16 is closer to 15. So this will be our answer. You can use the number line, or you can use subtraction. Subtracting 15 from 16 leaves 1, and subtracting 9 from 16 leaves 7, which proves through subtraction that 16 is a lot closer to 15 than 9. Let's try some out. First, split 12 into the nearest perfect squares, which are 9 and 16. Then square root these numbers. Then select the one that is closest to 12. The answer is 3. Now you try the others and turn your video off and check. The square root of 55 is between the perfect squares of 49 and 64. Square rooting them, we get 7 and 8, and we see that 7 is closer. The square root of 150 is between the perfect square of 12 times 12, or 144, and 13 times 13, which is 169. When we square root these numbers, we get a 12 and a 13, and the 12 is closer, or 144 is closer to 150. Next is estimating square roots to the nearest hundredth. We're going to use the example of 15 square root that we just did, and the problem to this point is exactly the same. But now we want to approximate the decimal portion of the square root. So we know that the square root of 15 is somewhere between 3 and 4. We have marked the number line off into quarters, 3.25, 3.5, and 3.75. We will begin our estimation at 3.75 because it's closer to 4, but we will just round it off to 3.7. And we will square that number to see what we get. Here I have done just that. 3.7 times 3.7 gives us an answer of 13.69, which is too small. It doesn't get to 15 quite. So I make my next guess and check at 3.8 times 3.8, which is 14.44, which is still a little too small. So I try again at 3.9 to 3.9, and it's just a little bit too big. So I'm going to make my final guess between 3.8 and 3.9 and make it 3.85. And we will use this as our answer because 3.85 times 3.85 gets very close to 15 at 14.8. So next, let's take a look at estimating cube roots to the nearest whole number. We'll use the example of the cube root of 58, and we begin by finding the nearest perfect cubes to 58, which would be 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and we notice that 27 and 64 are the closer or closest perfect cubes. So we're going to cube root 27 and 64, coming up with the answers of 3 and 4. And we will need to put a little 3 right here, so the cube root of 15 is between 3 and 4. If we look at our number line, 27 is here, and the cube root of 27 equals 3. And 64 is here, and the cube root of 64 equals 4. And 58 is here, and we can see by the number line that the cube root of 58 is closest to the cube root of 64, which is 4. You can use subtraction to prove which is closer. Subtracting 58 from 64 leaves 6. Subtracting 27 from 58 leaves 31. So undeniably, 27 is a lot further away from 58. So let's try some of these. The nearest perfect cubes to 62 are 27 and 64. And we will cube root these guys and come up with answers of 3 and 4. And 4 is closer, so it wins. Now turn the video off and try the next two. The nearest perfect cubes to 25 are 8 and 27. We cube root these numbers to get 2 and 3, and 3 is closer. Next we're going to cube root 129. The nearest perfect cubes are 125 and 216, so we're going to cube root these guys. And the winner and still champion is number 5. See ya.